Hi guys, so today we're going to apply the difference quotient to find a derivative. So I just kind of want to note a difference quotient is a fraction where you're going to find the difference between the y over the difference in the values of x, just like a slope. Now if I apply the limit as h approaches 0 in front of the difference quotient, that's when I can find the derivative. There is a shorter method, yes, called the power rule. However, the difference quotient is going to be the proof. So that's going to be chapter 1 of calculus and the lesson applied in pre-cal. So for instance, you're going to just get in the habit of saying the derivative of sine of x is going to be cosine of x, and that'll just come with enough practice that you'll have it memorized. However, the proof behind it comes from the difference quotient. So if you ever forget the derivative, you can always apply the difference quotient to determine it. Okay, so enough of fun facts. We're going to actually use it now. So I'm going to give you a function of 2x minus 3, and we're going to find the derivative of this function using the difference quotient. So notice I'm not giving you an x value, but even if I did, you would still fully apply the difference quotient before substituting whatever x value I give you, just like as I showed in the power rule. So just kind of make a note of that. We want to fully find the derivative using the difference quotient first. So notice that the first part of the difference quotient is f of x plus h. If I give you f of x, which is 2x minus 3, and I'm just going to kind of write it up here because I'm low on room. If I give you f of x equals 2x minus 3, notice that the only difference between f and f of x plus h is that I am replacing the x with x plus h. It's still the same function, notice f. I'm just replacing the x with x plus h. So that's exactly what you're going to do with this function. You're going to bring down the 2. You're going to bring down the minus 3. You are simply replacing this x with x plus h, and always substitute in parentheses. So what happens here is that to find out what f of x plus h is, I'm going to distribute the 2. So this gives me 2x plus 2h, and that's f of x. So applying the difference quotient, which is right here, I'm going to rewrite it. The limit as h approaches 0 of f of x plus h minus f of x all over h. I know, I can't draw a straight line. Okay, so from here, we already found f of x plus h. Remember that we found it up here. It's going to be 2x plus 2h minus 3. So I'm going to replace this. Let's use a different color. I'm going to replace this with its equivalent, which is 2x plus 2h minus 3. Technically, I should substitute it in parentheses, but there's nothing in front to distribute, so that's why I didn't, but I should. But since there's nothing to distribute, I'm going to leave it alone. And I'm going to bring down the minus sign. Now, I am going to substitute f of x. Anytime you substitute a function, it should be in parentheses, by the way, or substitute anything for that matter. So f of x is 2x minus 3. Make sure it's in parentheses because there is something to distribute this time. And then it's all over h. So bringing this down, what I have is 2x plus 2h minus 3. And I'm going to distribute that negative that's in front of the f of x. And that'll give me minus 2x plus 3, because that negative is technically a negative 1 that I'm distributing. So I'm just changing the sign when I multiply by negative 1. So that'll give me negative 2x plus 3. Again, all over h. And I'm going to combine like terms in the numerator. I have 2x and I have negative 2x. That's gone. I have negative 3 and I have a positive 3. So negative 3 plus 3 is also gone. And what I'm left with is, well, I'm out of room as well, negative or positive. Sorry, I cut myself off here. 2h over h, positive 2h over h. And then there's nothing to factor out because there's no plus and minus, which means we could just straight divide it out, leaving us with 2. So the derivative of 2x minus 3, and this is the derivative symbol, is just going to be 2. Final answer. And you can always check it with the power rule, but make sure you know the difference quotient. All right, guys, hope this helps.